Okay, good afternoon everyone. Welcome to the session today. The title you were expecting is Migrating from ArcGIS Runtime. That is the session that we're presenting. We changed the title slightly for the slides to say Migrating to ArcGIS Runtime 100. My name is Mike. I'm one of the product engineers on the ArcGIS Runtime SDK for .NET. I'm joined on stage by Eric here, who's one of the ArcGIS Runtime product managers. If during the session today we don't manage to answer any of the questions that you've come along to the session with, then we'll be available for a short while afterwards, but also we're available in the showcase area for the rest of the week. So this session is all about migrating to ArcGIS Runtime 100. Migration from ArcGIS Engine will form a large part of the session today, but I also want to talk about briefly some of the other SDKs that you might be migrating from as well. So the ArcGIS Runtime 10.2x generation. We had a number of releases over the last 4 years of the ArcGIS Runtime 10.2x series. The ArcGIS Runtime 100 was the result of a major API redesign and engineering effort to really build the ArcGIS Runtime on top of a common core, a common foundation for our functionality. So the bulk of the session today will be all about migrating from Engine and from ArcGIS Runtime 10.2x. There may be other SDKs that you used as well. So the ArcGIS Runtime SDK for Windows Mobile, that was a great SDK in its time. Significant because actually one of the use cases that ArcGIS Runtime fulfills was the same as that SDK for Windows Mobile. So it was a lightweight, nice, simple API and could connect to ArcGIS Server, download data sets, make edits and synchronize. So that's one of the use cases that the ArcGIS Runtime is solving. You might have also used the ArcGIS Explorer SDK, the .NET SDK for the ArcGIS Explorer desktop application. I mentioned that here. It's significant because the API that we designed and developed for that SDK was a greatly simplified API. We spent a lot of time thinking about what does a simple .NET API look like. And also significant because the team that spent time redesigning that API for the old Explorer SDK is still part of the team today that's working on the Runtime API. So those ideas and decisions and a desire for a simplified API carry through to the ArcGIS Runtime. And also map objects, of course. We couldn't run a session about migrating without talking about map objects. There may be unlikely many of you here are still using that, but I wanted to mention some of these other SDKs. So what's your migration path then from these SDKs? Well, really today we're talking about the ArcGIS Runtime 100, but it's also worth thinking about other options that are available to you on this, the new foundation of ArcGIS really. So App Studio for ArcGIS might be an option for you. You should take a look at that. The apps that Esri builds, so Collector, Workforce, Navigator, Explorer, those might also be options for some of the scenarios that you're catering for with the development that you've done in the past. Both App Studio for ArcGIS and Esri's other apps are built on top of the ArcGIS Runtime, so same capabilities are exposed to you through those. And perhaps also ArcGIS Pro SDK for .NET, so if maybe your engine development involved building kind of an ArcMap light environment, then maybe customizing the ArcGIS Pro application with the .NET SDK for ArcGIS Pro might be an option for you as well. But principally, this session is all about migrating from ArcGIS Engine and ArcGIS Runtime 10.2x to the ArcGIS Runtime 100. You might also think about why migrate other than product lifecycles. Well, the ArcGIS Runtime 100 is designed and built on a modern architecture. And the intent with that was to be able to support all of the ArcGIS capabilities across a range of different devices. So not just Windows and Linux, of course we still support those, but also Android and iOS as well. So the modern devices that people are using today and demand applications on, ArcGIS Runtime supports that range of devices. A modern architecture as well, so part of the re-engineering effort that we've been doing is building that on top of a modern architecture, so it supports 32-bit and 64-bit, takes full advantage of GPU resources where available, integrates with the hardware capabilities of the device, such as location services. And also supports modern ArcGIS capabilities as well. So the ability to talk to a portal, use identity management, sign into the portal, retrieve items from the portal, support the layer types that the rest of the ArcGIS platform supports, read and write maps to the ArcGIS platform. All of those modern ArcGIS capabilities are built into the ArcGIS Runtime 100. In talking to some of you already at the conference this week, I've had some interesting conversations about migrating from Engine. Somebody said, when do I need to migrate from Engine? And when we were talking about the lifecycle of Engine, they said, well, actually, I might not, because our goal is to end up with a web solution. They're going straight from ArcGIS Engine to JavaScript API. And they were wondering whether to use ArcGIS Runtime in the interim as a kind of a stopgap, really, before they reached a full web solution. That question, some of you might have that as well. It's hard to answer, but it depends entirely on what your Engine application does, what type of functionality you've got. So in some cases, I think people have been told they need to go from Engine to web. The person who's told them to do it isn't the person who actually has to implement all of that functionality in a browser-based environment. So that's a consideration as well. At the Dev Summit this year, we've reorganized the ArcGIS Runtime sessions. So what we wanted to do was reduce the number of product-specific, SDK-specific sessions. We have a range of those, one for each product, and they focus on what's specific to the platform about that product. So the ArcGIS Runtime SDK for .NET, for example, will be talking about things that are specific to the .NET SDK. But the re-architecting of the ArcGIS Runtime for version 100 built all of these SDKs on top of a common core, a common foundation, common architecture and design, and that really enabled us to produce a whole series of cross-runtime sessions. So there's a whole series of sessions this year at the Dev Summit, and they apply across all of the ArcGIS Runtime SDKs. And we're in one of those right now, migrating from ArcGIS Engine to ArcGIS Runtime. But we're not talking about a specific SDK. We're not talking specifically about the .NET SDK or Java, or those might be your natural choice coming from Engine, but iOS and Android SDKs and Qt are available as well. And really the re-architecting and the session organization gave us the structure for the session this year as well. So what we did was think about what are the capabilities in ArcGIS Engine and the applications that you built with ArcGIS Engine, what's the equivalent on the migration path in ArcGIS Runtime, and that common core that we're built on top of, then that actually gave us the structure for the sessions. So expanding out that core, then we thought about these functional areas: maps and data, editing, 3D, analysis, routing and geocoding. So what we wanted to do was talk about migrating from ArcGIS Engine, and we'll cover each of these areas in turn. As we go through each functional area, then, what we'll try to do is think about ArcGIS Engine to give you context for the, to kind of return you to the context of ArcGIS Engine, think about the documents and the data types and the workflows that you implemented in your applications, and the same thing for ArcGIS Runtime 10.2x, and then talk about what the equivalent is in the ArcGIS Runtime 100, what the promoted workflows are, and also some of the additional capabilities that will help that migration from Engine through to the ArcGIS Runtime. Okay, so let's talk about maps and data then. So first up, I'll make a comparison of ArcGIS Engine and talk about migrating to ArcGIS Runtime 100. So when you're migrating from Engine to the runtime, you're migrating between two different worlds in a way. So it's a world, for Engine, it's a world based on ArcObjects. It's the ArcGIS Desktop, ArcGIS Engine, ArcGIS Server environment. Migrating then to a world based on ArcGIS Pro, ArcGIS Runtime, and of course ArcGIS Portal or ArcGIS Online as well. So they are two worlds apart, but there are obviously things that carry over between them that make the migration possible. So in terms of the mapping formats, map types that you had within ArcGIS Engine, Well, the document types were ArcMap documents. You were able to work with MXDs directly in ArcGIS Engine. You could support map packages, the MPK format, layer files, LYR files, layer packages as well. As you went through that ArcGIS 8.x, ArcGIS 9.x, and ArcGIS 10.x generation. So in terms of those document types then, what are the equivalents within ArcGIS Runtime? So for map documents, MXDs, and map packages, we'll be talking about the equivalent in the runtime being maps from the ArcGIS platform and also mobile maps from ArcGIS Pro. So first up, let's take a look at maps from the ArcGIS platform. When I talk about maps from the ArcGIS platform, what I mean really is maps from portals, maps that are shareable between portals and ArcGIS Pro, and a map that you can open up in the ArcGIS Runtime as well, so a map that works across the ArcGIS platform. So it's read-write in those different environments. It's based on the web map spec, so it's a payload of JSON that goes to your client application. It contains online layers, so feature layers, map image layers, tiled layers, vector tiled layers, but also embedded content as well. So there's a concept of a feature collection within the web map, and that's the geometry attributes of features, but embedded within that web map document, or maybe embedded as a portal item and then referenced from that web map document as well. So it's principally online layers and content that's embedded within the web map. Web maps are interesting. They also contain app configuration properties as well. So they contain the ability to check that web map for whether the publisher wanted search enabled or measure enabled, or whether they wanted the ability to edit the particular layers of data. So as a developer working with the maps that are coming from the portal, you can actually check some of those properties. It depends on what type of application you're building. But as a publisher and a consumer of those maps, you're able to tailor the experience and embed some of that behavior into the map. Okay, so that was maps from the ArcGIS platform. Let's talk about mobile maps from ArcGIS Pro. So mobile maps from ArcGIS Pro then, it's a mobile map package, an MMPK format. It's based on the mobile map spec, which is essentially equivalent or a subset of the web map spec. Again, it's still based on JSON, although the actual file that you work with as a mobile map package is a single file. That MMPK includes the layers and data. So it's a package of content. It includes feature layers and tables, including related tables and attachments and associated things like that. It also includes tile layers as a TPK, and it also includes vector tile layers as a VTPK as well. So you've got the option then to include essentially your operational data and your base maps within that mobile map package. Mobile map packages also contain locators and networks. So it will take your ArcGIS locator that's referenced when you're creating that mobile map package and the ArcGIS network dataset, and it will convert those to a runtime equivalent of the network dataset and the locator for geocoding and routing within your runtime applications. So the mobile map package then contains all of that information, your operational data, base map, locators, and networks as well. So those were the two promoted workflows that I wanted to talk about. Maps from the ArcGIS platform, mobile map packages as well. There are some additional capabilities included with some of the ArcGIS Runtime SDKs that enable continued support for map packages, layer files, and layer packages as well that I'd like to talk about. And I got the reference there to local map service, local feature service, and local geoprocessing service as well. So I'll go on in the next few slides to talk about those in more detail. So first of all, for map packages, let's talk about local map and feature services. So map packages as a format that was supported in ArcGIS Engine continue to be supported in the ArcGIS Runtime with the local server component. So that's essentially, as you can see on the diagram on the slide there, local server is actually a bundle of Arc objects. They've been built specifically to support Xcopy deployment. In this case, it's not a set of Arc objects that you work with as a developer. We simply use those Arc objects to create local map and local feature services from the map package content and then provide a REST API onto that data. So it's available on Windows and Linux desktops, specifically with the ArcGIS Runtime SDK for .NET, the SDK for Java, and the SDK for Qt. You create map packages with 10.4.1, so you would need to repackage your maps to use with the local server because you would need to enable support for runtime. And what that really means is ArcMap, when it's creating that map package, it creates an MSD file, which is a map service definition file, and puts that into the map package. And that enables the local server to spin up either a local map service or a local feature service based on that map package. Let's talk about those same formats, map packages, layer files, layer packages in the context of local geoprocessing services as well. So again, we still support some of these content types from ArcGIS Engine, but via geoprocessing services. And what that really means is you, as a developer or a kind of author of a workflow, would need to write either a Python script or a geoprocessing model using Model Builder that can actually access that content, can access a layer file or a layer package or a map package. There are a number of tools available within the ArcGIS Runtime geoprocessing tools, such as extract package to get to the content. You could maybe rewire the data source for a layer file in order to support that, or maybe perform a data conversion, something like that. So it could be done either within a model or within a Python script. You create geoprocessing packages to do that, so they're created within ArcGIS Desktop. Again, it's similar to a geoprocessing package that I suppose you might create elsewhere in the system, but specifically it's created in ArcMap to support the ArcGIS Runtime. And again, just like with map packages where it creates an MSD file, there's a toolbox service definition file within the GPK, and that allows the local server to spin up a local geoprocessing service, and then via the Runtime API, it communicates over REST with that local service. Okay, so that was a discussion of the kind of map and content formats from ArcGIS Engine. Let's take a look at the data formats as well. So first of all, I'll talk about some of the local data formats, shapefile, personal geodatabase, file geodatabase as well, and their equivalents, the promoted workflows in ArcGIS Runtime as mobile geodatabases and shapefile. So I've got a note on there about shapefile support being on the roadmap for ArcGIS Runtime 100. I've got some slides later on about roadmap, and there is a session later this week about the roadmap for the ArcGIS Runtime, but I'll make several references to what's available now and what's available on the roadmap for ArcGIS Runtime 100. Okay, so talking about the equivalent of that shapefile, personal geodatabase, file geodatabase support in ArcGIS Runtime 100, the equivalent is the mobile geodatabase, a .geodatabase file created by ArcGIS. It's actually based on the SQLite format internally. That's kind of an implementation detail, but the benefit of that is it's portable, efficient. It actually, knowing that it's based on SQLite gives you, I suppose, some advantage. There has been a few cases, maybe the occasional bug gets reported, and because you're able to browse into the geodatabase file using a SQLite browser, that's in some cases helped to kind of diagnose the cause of the bug. So that's maybe useful debugging information as well. That mobile geodatabase contains the schema for the data, contains the data itself. It also contains the rendering information as well. So it's equivalent information to what you'd see in a feature service as the drawing info within the JSON from a feature server endpoint. You create these mobile geodatabases within ArcGIS Pro. So that creates a mobile map package that contains one or more mobile geodatabases. You can also create these mobile geodatabases from a sync-enabled feature service. Okay, so you publish a feature service as being sync-enabled, and then you request a mobile geodatabase from the service. You're able to make edits and then synchronize back, or just work with that mobile geodatabase in a disconnected fashion, if you like. There's also another workflow called Create Runtime Content. So that was available from ArcGIS 10.3, I think, and is still available in ArcGIS 10.5 today. The mobile map package is really a replacement for that Create Runtime Content workflow. I've got some more information on that shortly. So we talked about some of those local data formats. What about ArcSDE? So ArcGIS Engine had the ability to connect directly to ArcSDE and reference feature classes inside there. The promoted equivalent for that, promoted equivalent workflow, is a feature service. So feature services are hosted on ArcGIS Server. They allow you to display, query, and edit data in an enterprise or a workgroup geodatabase. The ArcGIS Runtime API accesses that feature service via a REST API, so it's making calls to the REST API to perform those operations. Feature services can be shared as web layers in your portal as long as the database is registered with your portal as by your portal administration tools. And you can actually create mobile geodatabases from that feature service as well. We talked about sync-enabled feature services on the previous slide. One of the things to note about access to data via feature services is that we talk about it being simple feature access or simple feature editing. What that means is you're working with point, line, polygon, multi-point geometry. You're working essentially with feature classes in the database. The thing that is simple about it is those feature classes don't participate in advanced geodatabase behavior, such as a topology or a geometric network, for example. Okay, so that was a note about ArcSD. Let's talk about raster data as well. So the promoted workflow for raster data within the ArcGIS Runtime 100 is direct read of raster data. So essentially equivalent functionality between ArcGIS Engine and ArcGIS Runtime 100 there, the ability to connect to and directly read multiple raster formats. The ArcGIS Runtime API has a number of raster renderers that can be applied by the API, such as a blend renderer or color map, hillshade, for example. There are also functions that can be applied on the fly to raster data, and if you're familiar with the image server component of ArcGIS Server, there's actually a subset of the functions of that, and these are things like pan shop and raster calculator, and they're applied on the fly to the raster data by the API. They don't make any change to the underlying data itself, just accessed and applied via the API. We also support mosaic datasets in the runtime. It's a runtime compatible mosaic dataset, so they can be created by the API itself. You can use the runtime API to create mosaic datasets, but also you can create those within ArcGIS Pro. You may be familiar with mosaic datasets. They've been supported elsewhere in ArcGIS for some time. They allow you to store and manage multiple raster datasets essentially as a single catalog or a single raster, and you visualize that as a single kind of mosaicked raster dataset, allowing you to apply a renderer or perform functions, apply raster functions on that dataset. So I talked about local data support, ArcSDE, raster data support. What about services support that you had in ArcGIS Engine as well? So there were a number of service types supported in Engine: ArcGIS Server map services and image services, ArcIMS map and feature services, and also OGC WMS service. Crucially, the one thing that was missing in ArcGIS Engine, I think, was ArcGIS Server feature service. So a lot of functionality in the ArcGIS Runtime today and the ArcGIS platform itself is based on access to feature services. We also support map services. And then I've got some notes about what's on the roadmap there. I've got another roadmap slide coming up that I'll talk through about some of the things that are coming up. So in terms of service types then, ArcGIS Server portal hosted feature services. It's a REST-based API. Map services and feature services I've talked a little bit about already, but briefly, map services are essentially dynamically rendering map images based on the extent and the query that you provide. They're based on pre-configured layers and renderers that the publisher of the service defined. It is possible with some map services, if the publisher has enabled this capability, to actually override the rendering, the labeling information, and even the data source. So it's a capability that the publisher of the service has to enable, and it's called the dynamic layer capability, but it allows you to essentially completely redefine the contents of that service. Feature services expose the feature, the vector data, so support display, query, and edit of features, allow you to extract a mobile geodatabase from that service, but also synchronize features, records, and attachments as well. So the promoted workflows I've just talked about, there are additional capabilities in local feature services and local map services. So just the same as I talked about support for map packages, another option for continued support for shapefile, file geodatabase, and ArcSDE content would be local feature services and local map services. So those types are still supported with local server. Again, that's available on Windows and Linux desktops with the .NET, Java, and Qt SDKs. The way to support that would be reference that content via ArcMap and create a map package with 10.4.1. You have the option of either containing the data within the package, in which case that shapefile, file geodatabase, or ArcSDE content will be converted to a file geodatabase and included within the map package, or you have the option of referencing that data in its original source location, either referencing the ArcSDE database directly or referencing the shapefile or file geodatabase on disk. In which case you need to make sure that the original location is accessible to your client application when it's opens that map package and starts that local map service or local feature service. So that was content about migrating from ArcGIS Engine to ArcGIS Runtime 100. Let's take a look at things to think about when you're considering migrating from ArcGIS Runtime 10.2x to ArcGIS Runtime 100. So I talked about with Engine how it's you're moving from one world which is firmly based on ArcObjects and ArcGIS Engine and ArcMap and ArcGIS Server. Migrating from ArcGIS Runtime 10.2x is kind of halfway along or maybe 2/3 of the way along that trajectory towards the full kind of ArcGIS Runtime Pro and portal model. So in ArcGIS Runtime 10.2x, we supported more of the service types. We were starting to work with portals and portal authentication, web maps, things, but the ArcGIS Runtime 100 is firmly in that new world. So let's take a look at just as we did with Engine, let's take a look at some of the document types that we worked with in 10.2x and think about their equivalent in ArcGIS Runtime 100. So we had available tile packages as TPKs, map packages, MPK via the local server. So for ArcGIS Runtime 10.2x, at least for the old WPF SDK, the .NET SDK, Java and Qt SDKs, local server was a substantial part of the original runtime story. During the lifetime of those runtime SDKs in the 10.2x generation, we also added create runtime content and also support for web maps as well. So I'll talk about what the promoted workflows for those are. Well, in terms of web maps, I've talked about working with maps from the ArcGIS platform, so that's essentially the web map covered. Also the mobile map package I've talked about as well as being one of the promoted workflows for getting content into your ArcGIS Runtime 100 applications. We still support tile packages as TPKs and vector tile packages as a new feature within the 100 generation. So the web map, ArcGIS Runtime 100 is a bigger change because it firmly adopts the web map or the map as a central concept of the API. So although we could work with web maps in 10.2x, it was always a slightly kind of peripheral workflow, and the support varied across the different runtime APIs. With 100, the API redesign firmly puts that map at the center of the application. So you have a map and a map view, and the content within the map matches that fundamental layer model within the web map as well. So you work with operational layers and base map layers as well. In terms of create runtime content, then that's largely superseded by the mobile map package. It contains the same content as that create runtime content workflow in terms of mobile geodatabases, tile packages, the runtime compatible network dataset, and a runtime locator, but it adds support for mobile maps. So maybe one or more maps inside that mobile map package. It also adds support for including vector tile-based maps in there, and they're created in ArcGIS Pro. So mobile map packages created in ArcGIS Pro. Create runtime content was an ArcMap workflow. Tile packages still supported within ArcGIS Runtime 100. They're great for continuous raster data or image data as well. But really, We think for many scenarios, many use cases, for your vector data, you'll be moving to use the new vector tile package, so the VTPK format. That contains a collection of vector tiles and style resources for your data. The vector tiles contain vector representations of your data, so you don't have access to the original data within there, but it's kind of a vector representation of your data. One of the really exciting things for Runtime and the devices that Runtime is being deployed to is they display really well on high-resolution devices. So very high-resolution iOS, Android devices, for example. They can also be customized on the device to support different display types. For example, switching between a day and a night mode can actually be done client-side without regenerating the entire cache. They're also much faster to generate, and they have a much smaller footprint on the device as well. So vector tile packages is a really exciting development, but like I said, there's still a use case for tile packages with continuous raster and image data. Let's talk about map packages again briefly. So the mobile map package is intended really to supersede the map package. That mobile map package, as I talked about, contains that vector data, contains base maps, contains a locator and a network. But we do still support those map packages within the ArcGIS Runtime 100 via local server. So there are some changes when moving from 10 to X, specifically to talk about here. So the local server has been separated from the ArcGIS Runtime SDKs and been made available as a standalone download. So you log on to the developer site, go to your download section, and download the local server SDK separately from the other SDKs. It's still available on Windows and Linux, and still with the .NET, Java, and Qt SDKs. They contain APIs specifically to talk to the local server. Map packages should be created with ArcMap 10.4.1. So I've talked about how within the local server there's a bundle of Arc objects, while for ArcGIS Runtime 100 those Arc objects are essentially based on ArcGIS 10.4.1, and that means we recommend using ArcMap 10.4.1 to create your map documents to work with the local server 100. But I said that we see that mobile map packages will gradually supersede, or generally even now in many cases do supersede those original map packages. And so what we'll see over time really is a lessening of emphasis on local map services and local feature services, and local server being promoted primarily for local geoprocessing services. So the 360 approximate tools that we support within the ArcGIS Runtime local server, that's really where we want to focus attention for the local server. It's going to take us a long time to rewrite those in the ArcGIS Runtime. Okay, so that was, we talked about some of those data, map contents rather, so map packages and tile packages and things. Let's take a look at some of the data formats that you had available within ArcGIS Runtime 10.2x and what the promoted and equivalent workflows are in ArcGIS Runtime 100. So on the left-hand side is the formats that were available to you in 10.2x. Some of the SDKs supported that mobile geodatabase. Some supported shapefile. We had map, feature, and image services. Also OGC, WMS, WMTS, KML, and some other tiled services, Bing and OpenStreetMap, CSV, GeoRSS, S57. So actually 10.2x supported a lot of formats. In the re-engineering effort of ArcGIS Runtime 100, we had to delay releasing some of those data formats back into the API. So primarily at the moment we have support for mobile geodatabases, raster data, which is a new format that wasn't available directly within 10.2x. We support map and feature services still, but there are some other things that are on the roadmap. Okay, so I mentioned the roadmap a few times. Here's the roadmap for maps and data within ArcGIS Runtime 100. So we're considering some mobile map package enhancements. So one of the features that we're working on at the moment is the ability to actually take maps offline. So open up a portal map and then ask for that entire map offline. What that does internally is use the various different tasks like generate geodatabase task to get geodatabase of your features. It uses the extract tile cache task, for example, to get a TPK, or the extract vector tile cache task, but it's simplifying that API, so you as a developer are able to just say, take this map offline, and then the result is a map package, a mobile map package that you can work with. We'll be reintroducing ArcGIS Server image services. So part of that work involved, because we support raster data directly within the ArcGIS Runtime API, we're able to support those ArcGIS Server image services as a raster layer within the API, and that means applying renderers client-side and also applying those functions as well that I talked about. So we have some client-side functions and then the ability to apply those raster functions server-side on the image service as well. Support for WMTS, WMS will be coming as well. OpenStreetMap and Bing, so you can see some of those are related layer types. WMTS, OpenStreetMap and Bing, they're all essentially tiled layers, so relatively straightforward to implement. KML, shapefile, S57 implementation as well, and then a future thing would be utility networks as well. And really that seems like a lot of things on the roadmap for ArcGIS Runtime 100, and it seems like quite a lot of features that were not included in the initial API compared to 10.2x. But really the process we're going through at the moment is realizing the benefit of all that re-architecting and re-engineering, that it's much faster now for us to re-implement these features and realize those in all of the ArcGIS Runtime SDKs at one time. So that means in each release as we go forwards, each update to the ArcGIS Runtime release, we're able to ship each of those features on all of the platforms instead of one at a time in a kind of staggered release. So we're really realizing the benefit of that re-engineering effort. There's a list of recommended Dev Summit sessions. I won't spend too much time talking about this, but these slides will be available to download afterwards, and all of the sessions are being recorded, so you can use this as a reference to navigate to other sessions that we would recommend watching. Okay, let's take a look at editing, and specifically moving from ArcGIS Engine to ArcGIS Runtime 100. Again, as I talked about before, you're moving from this ArcObjects-based world to a world based on ArcGIS Runtime, ArcGIS Pro, and Portal. So for context, editing within ArcGIS Engine mirrored the workflow within ArcMap. So you were able to edit a number of different data formats: personal geodatabase, file geodatabase, ArcSD geodatabases, and shapefiles. The editable content included simple features, so feature classes, point line polygon geometries, but also complex features as well, so geometric networks and topologies, and geodatabase schemas. So Engine did allow you via the API to perform some geodatabase management. And the workflow involved working with interfaces, setting your target vector data set. It was all based on edit sessions, sketch operations, edit operations, and for offline editing and disconnected editing scenarios, Engine used the geodatabase replication. So for example, the checkout, check-in replication process. So moving to the ArcGIS Runtime 100 world then. So we'll be talking about feature services, mobile geodatabase, feature collections, and shapefiles as well. So in terms of what's editable within the ArcGIS Runtime 100, you can edit feature services. If you're in a connected mode, your application has connectivity the whole time, then you can edit feature services. The mobile geodatabase, so if you publish a sync-enabled feature service, request a mobile geodatabase from that service, you can make edits and then synchronize them back. And then I also talked about feature collections earlier. So feature collection is another type of content that can be edited. So you open up a map from the portal, that map contains an embedded feature collection, you edit those features, save that map back to the portal, and other people using that map will also see the edits that you've made. The editable content within ArcGIS Runtime 100 is based essentially on simple feature editing, so there isn't access to the complex behaviors that I talked about in terms of topologies and geometric networks, for example. But you can edit the different geometry types and also features, their attributes and attachments. So let's take a look at ArcGIS Runtime 10.2x to ArcGIS Runtime 100. Well, some of the things that I've just talked about obviously still apply to ArcGIS Runtime 100. There are some specific considerations here. In 10.2x, we supported essentially very similar editing workflows. online feature service editing, offline the mobile geodatabase editing and synchronization. We placed, I think, a lot more emphasis in the 10.2x generation on using map packages, the MPK format, with local feature services and editing those. That's a valid workflow, but it's much more complicated arrangement than actually working with feature services and working with sync-enabled feature services to get mobile geodatabases. So that would be a sync-enabled feature service, and a mobile geodatabase would be the promoted workflow. So ArcGIS Runtime 100 supports many of the same formats as 10.2x. I talked about adding feature collections to that as a new type of content that's editable. And then we do still support that MPK map package format via local server that I talked about, but really the promoted workflow is mobile geodatabases. So what's the workflow when you're editing content within ArcGIS Runtime 100? Well, you work with feature tables, whether it's a feature collection table, or it's a service feature table, or it's a geodatabase feature table. You ask that table to create a feature based on the schema, or you get a feature from the table. You make edits to that feature, so maybe you modify the geometry, the attributes, or the attachment, and then you apply those edits back on the table via the asynchronous add, update, delete operations. Once you've applied those edits to the table, then those edits need to be pushed back wherever that table came from. So in the case of an online feature service, there's an apply edits call to push those edits back to the service. Or if you're using a mobile geodatabase that's come from a sync-enabled service, then use the geodatabase sync task to resynchronize with the original feature service. If you're editing a static feature collection table, so that I talked about those feature collections coming from a map or as portal items, then you need to either save the map or you need to save the portal item that the feature collection came from. So what's on the roadmap for editing in ArcGIS Runtime 100 then? Well, we're adding read-write support for shapefiles, read-write support for KML. Probably further out on the roadmap are things like being able to edit mobile geodatabases inside mobile map packages. So right now a mobile map package is read-only, but we're looking at being able to edit those geodatabases and then take them back into ArcGIS Pro. And then another feature that's not, as far as I'm aware, hasn't been available in the 10.2x generation of runtime, and something we're looking at is one of the feature service capabilities about being able to apply edits at the root level of the feature server. So apply edits to all of the layers that you've edited within that feature service, and then roll back if there's any failures. I know that's a key requirement in many workflows, and we're looking at how we can support that within the ArcGIS runtime in the future. So some recommended sessions to take a look at the Dev Summit then: editing your data online and offline, and also working with maps online and offline. We'll go into much more detail about all the different content types that I've talked about. Okay, what do you think? Have we got time to keep going? Yeah, okay. Okay, so the next, I've talked about maps and data and editing. Those formed the bulk of the session. I've got a few more slides to talk about 3D analysis and also routing and geocoding. So migrating those workflows from ArcGIS Engine and the ArcGIS Runtime 10.2x SDKs to ArcGIS Runtime 100. Okay, so 3D within ArcGIS Engine, you were working with globe documents, scene documents, the 3DD and SXD documents, working with multi-patch feature classes to provide your 3D content. You had in the API a globe control and a scene control. In 10.2x, 3D was available, in fact, only in the ArcGIS Runtime SDK for .NET from 10.2.6 through the 10.2.7 release as well. Most 2D content was supported in 3D, so tiled layers, feature layers, for example. 3D content came in the form of scene services, so online connected scene services, but also 3D specific symbol and renderer types that you could apply to graphics and features. We did support raster data, but only for elevation, so not for visualization in 3D. And the types were a scene view and a scene, so separation of the view from the scene there. So in comparison then, when migrating to ArcGIS Runtime 100, well, 3D is available in all of the ArcGIS Runtime SDKs. In the 100 release from November, it's 3D as beta on mobile devices, and we're looking to stabilize that and release that fully in the upcoming update. We support scene service layers, so there's online connected scene services, published using ArcGIS Pro, available with ArcGIS Online and ArcGIS Enterprise. We also support scene layer packages, so effectively the offline equivalent of that scene layer service. Again, created using ArcGIS Pro, and you can use them disconnected from the network. Elevation services are supported, so elevation services published to your ArcGIS Enterprise or online, but also local raster data sets are supported for elevation as well. Key API types that you're working with in Runtime 100 for 3D, so the scene view and the scene. So those concepts that we had in the .NET SDK for 10.2.7 and 10.2.6 carry through. You can see the same pattern of map view and map and scene view and scene, so we've tried to keep the same design patterns as we go through there. Surface is for defining elevation. The ArcGIS scene layer works with scene services and packages, and then there are specific symbol types and cameras for working with viewpoints and navigating the scene. So the roadmap for 3D then, within ArcGIS Runtime 100, support for the web scene, to read and write of web scenes, location display on scene view, that's a feature that's not in the initial 100 release, vector tile support in 3D, a sketch editor on the scene view, and also local scenes as well. So some of these are more research-based, but the ability to support that kind of fish tank local scene view in a variety of different projections and work with subsurface data as well will be something that we're researching and looking to implement in a future release. So recommended sessions about 3D, and there's a session on building 3D applications and also the API and architecture session as well. Let's take a quick look at analysis as well. So for context, we'll look at ArcGIS Engine briefly. Analysis was based on establishing topological relationships, so working with interfaces such as topological operator. Analysis of layers, processing of data was achieved through geoprocessing, and there were also extensions as well. Network analyst, spatial analyst, 3D analyst allowed you to access to additional geoprocessing and ArcObjects capabilities within ArcGIS Engine. In 10.2.x, analysis was based on, in some cases, geometry service. Some of the 10.2.x APIs supported working with geometry service for that equivalent of establishing topological relationships between features. The geometry engine is essentially the local version of the geometry service, supports the same capabilities, works on individual geometries. Geoprocessing services were supported and disconnected via the local server, but also visualization as well as a form of analysis. So that's 10.2.x, and then in ArcGIS Runtime 100, geometry engine continues, so the ability to establish those topological relationships as part of your analysis workflows using the geometry engine. It's very fast, very efficient, synchronous operations, works on individual geometries. Geoprocessing is available as local geoprocessing services using local server, so spin up a local geoprocessing service using a geoprocessing package authored with ArcMap. Geoprocessing services are also available with ArcGIS Server and also ArcGIS Online as well. So there are spatial analysis services hosted by Esri that provide analytical capabilities. The roadmap for analysis in the ArcGIS Runtime 100 then. Additional geoprocessing tools for local server. We determine that list primarily on what you ask for. So if we hear requests for additional geoprocessing tools, then we'll look at whether we can support those, work out what the correct licensing is, any additional ArcObjects that we might need to include in that local server to support those tools, but we're open to a request there. Additional renderers and additional support for smart mapping to support those maps that are coming from the ArcGIS platform. And we're also investigating 3D operations, on-the-fly visual analysis such as viewshed and line of sight, so very fast on-the-fly visual analysis, particularly in 3D workflows. So we have an analysis session later in the week on the ArcGIS Runtime that I would recommend attending if that's one of your workflows for migrating. So we're moving through that core set of functionality down to routing and geocoding. So for context, again, ArcGIS Engine routing was based on ArcGIS network datasets, required a network analyst extension, executed via ArcObjects or via geoprocessing tools, or you could use ArcGIS Server network analysis services. A number of different solvers were available to you in Engine, and geocoding was performed on ArcGIS locators, again executed either via ArcObjects or via geoprocessing tools. In 10.2x, the concept of network datasets from ArcGIS and locators continued, so we supported routing based on those network datasets. We supported the ArcGIS Server network analysis services, so there's some specific ArcGIS Server optimized services for service area, closest facility, and route. They were mirrored by tasks within the API, so route task, closest facility task, and service area task. The 10.2x SDKs supported closest facility and service area online only. And then geocoding worked with an ArcGIS locator, executed via the locator task, either online or working with local locators. So moving through to ArcGIS Runtime 100 then, really many of the same concepts apply, working with ArcGIS network datasets, working with those specific optimized analysis services, network analysis services in ArcGIS Server, mirrored by specific API task types, routes, service area, and closest facility. The ArcGIS Runtime 100 provides a local equivalent of those as well. So now in 100, we're going to be adding on the roadmap a local service area task and a local closest facility task. Those network datasets are packaged into the mobile map package and accessed via the API from the mobile map package. Geocoding, again working with ArcGIS locators, published as services using the geocode server endpoint, or packaged within a mobile map package from ArcGIS Pro and then accessed via the locator task. And what we tried to do in both of those cases for routing and geocoding is make sure that the API, whether you're working with online content or local content, is exactly the same. So you just need to switch the content type, but the API for working with it is identical. So the roadmap for routing and geocoding in ArcGIS Runtime 100 then, the local service area task and a local closest facility task. And recommended Dev Summit sessions this week. Building a routing application I recommend attending that one if routing and geocoding is part of the workflow that you need to migrate to ArcGIS Runtime 100. Some additional resources then. We've very recently published a guide topic in our developers site on migrating to ArcGIS Runtime 100. So there's content in there specifically about migrating from 10.2x to 100. It's available right now in the .NET guide and also the Android guide as well. If you're using some of the other runtime SDKs and looking to migrate, actually many of the concepts in those two documents will apply to the other APIs as well. Okay, so what else do you need to know? Well, now I'm going to hand over to Eric, who will take you through some additional discussion.
Great, thanks Mike. Can you hear me? Back there? Okay. That was great. There's a lot to think about, and I'm going to just kind of add some other, I'll need to switch over to 4 here, however that works.
Good.
Oh, there we go. And a couple of those other housekeeping types of things when you're thinking about the migration that you're going to be doing is planning on what the timelines are, right? So 100 ArcGIS Runtime SDK 100 version was released in November 21st, last fall, and that's now in general availability. That general availability will go through October 2017. Then it'll go into an extended support all the way through October 2018, and then mature for a 2-year period. and before it's retired in 2020. So 100 and all the updates that go along with 100 lifecycle will follow through that period of time. You're doing 10.2x projects right now. You're working with that. You already have deployed applications. Have no fear. We have a plan that we think will satisfy everyone that will now bring 10.2x currently now into extended for a period of 2 years through November 2018. So at this stage, you can have some comfort time in planning your migrations and have your applications that are currently on 10.2x supported. Then we'll have follow that up with 1 year of mature before it's retired. In 2019. We think that's a good time, but we'd love to hear your feedback to see if that's not sufficient. But we feel it's a good time and a good overlap to help you in the migration period. So what does extended support mean? A couple things to keep note of. That's a period of time when hot fixes and patches are entertained as far as being releasable to you for fixes that come in that need to fix the product. Also get tech support during this time, but there's no new platform certification during extended period, but we still entertain the notion of being able to deliver hot fixes in critical situations. The mature phase is tech support only, so it's important to know when you think it's going to be okay to just keep your applications cruising until you have time to migrate. So that's life cycle. If you're moving from or planning your movement from ArcGIS Engine to ArcGIS Runtime, the Engine product was released at 10.5, was released last December, and as you can see over in the retired side, you have plenty of time through 2022 to have supportability for your Engine applications at 10.5. Of course, that goes a little bit, pinches you a little bit more as you go down that list there in the version column to see what the times are that support ends. But we feel that that's a good time for you to be able to plan your migrations from Engine. So some reminders and some things that are good for you to keep track of. If you look on our support.esri.com, you'll find our product life cycles. It's a good idea to keep looking at those and keep up to date on when things are moving into different phases of support. And then it's also if you have applications deployed using Java or cross-platform C++ onto the Linux platforms, it's important to note that the deprecation notice had gone out. Every year we put, for every release, there's a deprecation notice of things that we're deprecating and plans that are going to be changing for that particular release or releases to come. That Java Engine and C++ cross-platform Engine had its last release at version 10.4.1 of ArcGIS. That means that you'll have support through 2022 on Linux and for Linux, Java, C++, but beyond that, there won't be any more releases for that particular platform stack. So it's important to note that if you're on those, it's a good time to be looking at the Java and Qt SDKs for ArcGIS Runtime to support your Linux platforms. That's where all the innovations will continue to go. Where to start when you're planning your migration, all the way from preparing your data with all of those tips and tricks that Mike had shown, all the way through development and writing code for your applications. There's a great resource that we released last week called Dev Labs. You can get to it from developers.arcgis.com/labs. And it gives you a pathway to take your data, prepare it through 15-minute lessons, sometimes 10-minute lessons at a time, and then also build on from there to take those labs into the design phase to help you style your maps and create your data for preparing it for being viewed and worked within your runtime applications. And then the Develop tab gives you a number of labs that take you through whatever API you're going to have. We'll continue to grow those. Oh, you can't see that, can you? I'm sorry. Probably can't see that. Anyway, /labs from developers.arcgis.com. I apologize, you can't see that right at the moment. So let me go back to the slides there. Okay, also something to keep in mind in developers.arcgis.com /pricing. You'll see the developer subscriptions that have just been released that give you a scale-up opportunity for different levels of developer subscriptions that are tailored for exactly what you need to do in dev and test and build. So that's developers.arcgis.com/pricing. That's an excellent resource for you to take a look at to see what subscription level you'll need to be at. And then, as Mike mentioned, we're going through and having a series of updates this year for quartz. So update 1 is coming in May, and that will focus on equivalency with closing the gaps and with 10.2x technology and bringing that equivalency of 10.2x to 100. And then in the fall, we have an update 2, and that should complete our, what we would call our engine release. That'll complete filling the gaps that we have so that engine developers can now fully begin their migrations and have that support in ArcGIS Runtime. Again, Mike went over some of these sessions and he highlighted those, so I just wanted to put them here, but he already covered them. These are the cross SDK sessions that you want to take a look at, and if you have the app on your phone, it's a great resource to go through and sort on runtime and add reminders for some of these sessions. And then the SDK specific sessions that we'll be giving throughout the week, they're here in this green box here, so keep an eye on some of those that'll tailor you your learning for those specific SDKs that you're in. So just to summarize, and I know we're 2 minutes over, we went through the architectural differences between the products, but the benefits of using the ArcGIS Runtime current version 100 to take advantage of the WebGIS model and all of the things that you've seen at the plenary to continue forth taking advantage of a lot of those things you'll find in 100. Know where the right migration paths are for you. It's very important whether you're going from Engine or 10.2x. We hope that you'll refer back to this session so you can see where your migration plans should fit. Again, great starting points of educating yourself on the new design, develop paradigm and preparing your data paradigm for ArcGIS Runtime 100 and going forward, /labs off of developers.arcgis.com. And so with that, I apologize for going over. We thank you for your time. We can have questions at this time. Yes? The question is in our slide that we had for timeline of supportability for the life cycle, we had runtime 100 ending its support life at 2020. That's 100.0. So 100.1 will start a brand new life cycle, starts its own new life cycle. The 100.0 whatever will not start the clock all over again. Does that make sense? So 100.1, 100.2, those begin a whole new GA extended mature going forward. And the reason why we do that is because we're adding significant functionality at that stage. So if we add direct read of KML in the middle of that product lifecycle, they don't have support long enough. Does that make sense?
Yeah. Okay. So then, when we operate 100.0 and then 100.1 comes out in May, that's not going to be a big overhaul, right? That's like swapping out library references.
Right. So the question is, 100.1 is that going to break backward compatibility of 100.0? No, it'll build on that architecture, increasing the functionality that we need to continue to complete equivalency with 10.x.
Yep.
Thank you. Yes, in the back.
So, as a framework, and it does sound like it'll be scaled up on top of the 100.0. That pretty much answered it. Do you anticipate that these life cycle links will be somewhat consistent of 4 years? Can we expect between .1, .2, whatever, about 4 years of a difference? And then the other question is, just a general question of how much you'll support the C# workflow in the future for geoprocessing. I know a lot of analysis is moving towards building out Python. I noticed that ArcGIS Pro SDK has a lot of the similar functionality of ArcObjects, but I wondered how much you'll be kind of continuing that process past 100.0.
Yeah, there's a lot there. Do you want to take a stab? Or you want me to start off?
Yeah, I can answer the second question.
Okay. So the first part of the question was, do we anticipate this product lifecycle to be for 100.1, 100.2 going forward, right? And we plan on these, right at this stage, we plan on these 4-year cycles, right? This is what we'd call at every .1 or .2 that adds feature functionality, we call this a 1-1-2 model, right? 1 year of GA, 1 year of extended, and 2 year of mature, right? And we plan for those dot releases. The dot releases within those cycles will not tick the clock, so those will fall in line and begin and have the same end date as the dot releases. If there's a 100.2, for example, that has a .1 after that, then that will pick up at the life cycle where it began, right? So, does that make sense? Okay.
And then in terms of C# access to geoprocessing tools, it's something that we do want to provide. A big part of analysis and geoprocessing within ArcGIS Runtime 100 continues to be the local server or online geoprocessing services, so executing those geoprocessing models and Python scripts. I talked on the roadmap about how we're researching some kind of on-the-fly visual analysis operations, view shared line of sight, and over time the goal will be that we'd have an increasing set of analysis functions, geoprocessing equivalent functions that we can call directly from C#. But it's going to take a long time to implement those. So for now, definitely the recommended way is to use Python, model builder, geoprocessing services, geoprocessing packages, and work with those.
Yes, sir.
Are there any plans to support complex feature editing in the future?
Complex feature editing in the future.
There are plans to, yes, depending on what type of content you're talking about, but for example, geometric networks, yeah. So the support for geometric networks or the equivalent functionality in the ArcGIS Runtime will be the new utility network. So that's being implemented in ArcGIS Server as services at the moment, and then it will come to kind of desktop or Pro, ArcGIS Pro, and it will be, we're looking at implementing support for utility networks in the runtime probably available next year, so 2018 timeframe.
But I think the question also included an editing workflow, right, within runtime of geometric networks? Is that what you were asking?
Not
Oh, okay. I thought I heard editing.
with the support for complex editing.
Yeah. And maybe, I don't know about topology. I saw that on a slide in the plenary this morning, but that's further out. But certainly the utility network is coming to the runtime probably next year.
And then we'll be around. Oh, sorry. Mike and I will be around at the, well, he'll be in more sessions than I will, but we'll be around at the showcase. Love to talk to you about migration, more of your workflows and wherever we can do to help. So we really thank you for your time. I apologize for going over. This is the /labs where you can take these tours going through data preparation, so you can take a lab that takes data and you work through this progressively into designing your applications and your web maps, and then to develop. And this is live now, so you can see these, the various tutorials that take you through these labs here that build on each other. So this is a good migration tool to help wrap your brain around what we have to do. So sorry I didn't have this shown up during the presentation, but developers.arcgis.com/labs. And it uses a lot of the open data that's available through the LA Hub, LA City Hub, and so you can get a vision for how that all works, but take your data and pour it into these labs as well.
All right. Okay, thank you very much. Yeah.